Well, hey everyone, Jason here from Alorium Technology, and in this video I'm doing something a little bit different. And I'm doing it because it's fall, and the trees are finally dropping their leaves, the air is getting crisp, and this is a great time of the year to be outside. So I want to provide an update to this video idea that we introduced a little while ago about doing inline data compression for an XBee low power wide area board. What we're going to do now is show you an update to that. All right, so what I'm going to do in this video is I'm going to show you how we can use our compression module, which we've named XGZ kind of in the interim until we come up with a name for what we want to call it full time. That's the name that we chose. And really the idea there was we were doing gzip compression for the XBee footprint is where this started. But of course it's not limited to doing DIGI XBee. We could use it with all kinds of modules, whether that was from some other companies like maybe NimbleLink or Multitech or any other company that essentially makes these wireless modules or cellular or whatever. We could use them with those too. Probably a bunch of companies I'm not even thinking of, maybe even satellite, who knows. But what we did as a starting place was use this DIGI XBee footprint so that it was really easy to integrate into an existing solution. Now what you can do is you can just take, like if you see here, I've got an XBee cellular module. This is the LTE-M and NB IoT version for AT&T. And what I can do is, let's say you have an example, and let's represent your project with what in this case is just this simple SparkFun little adapter board. And what I'm going to do is, if you could just simply pull this module out, and then you could drop our XGZ board right in there and put the cellular module back in on the socket. It's it's set up to just be able to drop right in between, kind of make a little sandwich out of our board, if you will. And since it's hooked up to cellular or to UART, a lot of these XBee modules communicate over UART. Some are I2C, some are SPI, I think, but most of them seem to be UART, so that's the one we chose. And it's very easy to simply just hang right off that UART bus. And what this does is it allows you to simply just grab the data coming across the UART, compress it in line, and then we just pass that right through the XBee module. And now what we're doing in this case, just to give some way to show it, is we're compressing a data stream and we're shipping that through the XBee cellular, and we're just sending it to a server we have that's offsite or at least leaves our network. And then we're just posting that gzip data file so you can see the size of the data file. So we know the starting size of the file and the ending gzipped file that we sent. And so that's essentially what we're doing with this particular setup. Now, what I've also done is, instead of just connecting to it with like a serial, like CoolTerm or something like that, and typing data or sending a file, I've got this Raspberry Pi that I'm using, and I'm using that to send a variety of different kinds of data, right? I can send, I can go scrape website source, I can send some canned or pre-set up JSON files or MQTT or something like that. And that's actually pretty cool. Pretty good way to do it and kind of demonstrate different types of data, because the compression results you get are highly dependent on the data that you're sending. And that's just the nature of gzip compression. Keep in mind, what we're doing here is gzip. So really good for things like ASCII text and that kind of stuff, because it tends to be a good candidate for compression. Not great for video, not great for images, because those things are generally already compressed, and so they're not a great solution, or it's not a great solution for that. Again, I'm not in front of my computer right now, so I don't remember the exact numbers, but what we can see is when we send, if I go out and scrape a website source, right? So let's say I go out and I grab the data from our website, AloriumTech.com, and you can look and you can get an idea of what the compression ratio is. From memory, I think it's around 3 point something to 1, which is right around 3, something like that, is pretty standard from what I've seen on different websites I've tried. Some are up into the 4s, some are in the high 2.8, 2.9, something like that. Pretty standard for a website source. Of course, a lot of repetition in those. And then things that are highly structured, like JSON files or MQTT, you can get even higher compression ratios than that. If you send truly random data, it's not so great, right? I think most of those, I have this option here where I can send truly randomized data, and I think the compression ratios for that are somewhere in the 1.3 usually, something like that, which is about right? That's kind of the idea with random. is there's not a lot of repetition, and so the compression isn't going to be all that great of a solution. But I don't get the sense that for a lot of IoT applications, there's a lot of random data being sent. There is a lot of duplication in the file format itself, just by nature of the fact that there's a lot of JSON used as kind of the vehicle. So, oh, here comes the bus. I don't want to get run over, and it's going to be loud. Well, that is it for this video. Thanks for watching. Hopefully this whole concept works out and it's not too annoying with the way I'm kind of walking and you're getting a little bit of bouncing and jostling in motion. But hope you enjoyed it. Leave us your feedback and keep your eyes open. I'm going to follow up really quickly here with another video talking about the advantages, potential advantages of using data compression in your IoT endpoint solutions. So that is it for this video. Take care. Thanks again for watching.